Hello, and welcome to our webinar, Leveraging Advanced Analytics for Improvement in Process Manufacturing with Seeq and Swan-Black. A few things to mention before we begin. Please submit your questions through the questions section of the GoToWebinar console. If we do not answer your question during the session, we will follow up with you afterwards. For any additional questions, please email Joseph Gardner at swanblack.com. Our presenters for today's webinar are Joe Gardner, Practice Lead at Swan-Black, and Nicholas Gelati, Seeq Analytics Engineer. And with that, I will hand it over to Joe.
Great. Thank you, Elise. Good afternoon. Thank you all for joining us. I hope everyone is doing well and staying healthy. Certainly appreciate you taking the time today. A little bit about myself. I'm Joe Gardner. I lead an advanced analytics practice called Swan-Black. Swan-Black is an operating affiliate of GS Systems, who has served the industrial manufacturing industry for over 25 years. We have extensive experience working with customers in the chemicals, life sciences, food and beverage, power, and CPG industry verticals. By background, I have a master's degree from the Kelley School of Business at Indiana in business analytics, and have spent most of my career working in a consulting capacity, helping customers generate meaningful insights from their disparate data sources. For those who haven't heard of or worked with us in the past, Swan-Black is an advanced analytics practice that helps accelerate time to insight for process manufacturers. Our partnership with Seeq is a means for interacting with our customers and empowering them to make decisions based on insight rather than intuition. We're a Seeq certified partner with Seeq certified analytics engineers on staff. Basically what this means is that we've gone through the certification process to be able to provide the highest level of service to our customers through Seeq. In today's world, we're being forced to think differently about our production data. Being able to access your data remotely is quickly becoming a necessity. It is important that process engineers be able to perform root cause analysis to generate, share, and collaborate process data insights that help improve production outcomes. We'll showcase some sample use cases today that can quickly help industrial manufacturers, regardless of industry, improve these production outcomes and accelerate time to insight with advanced analytics. I will circle back at the end, Nick and Elise, if there are any questions that the group might have, but otherwise, Nick, I'll kick it to you and you can take it from here.
Thank you, Joe. So there's a couple topics that I'd like to cover today. First, what is Seeq, why you should use Seeq, how you can use Seeq, and then finally, we'll look at some examples of how our customers are using Seeq to solve their problems. But first, we'll start with the basics. What is Seeq? Seeq is an advanced analytics solution for time series process manufacturing data. Essentially what that means is that Seeq sits on top of your data historian, reads in all your data you're collecting, and allows your engineers to analyze that data in a very simple way. You can then use Seeq's analytics tools to investigate your data and share all of that insight with operations or other members of your team to improve performance and efficiency. Seeq allows engineers and subject matter experts to get the most value out of the data they are already collecting. To understand why you should use Seeq, let's take a look at the workflow we see in place for engineers in common process environments. So there's a lot of data historians where tons of operating data is being collected. Process environments typically run continuously, which means that all of this data is collected continuously, sometimes as frequent as every second or faster. If an engineer or subject matter expert wants to use this data in any way, the first step is generally to download that data to some sort of spreadsheet application, such as Excel. As soon as the data is downloaded to Excel, for example, not only is all the data completely duplicated from the historian, but the spreadsheet is immediately out of date since the process is continuing to operate. What's important to note is that spreadsheet applications are not designed with the tools that you need to analyze process time series data. And there's several reasons for that. The first is that real-world process manufacturing data is not perfect, and often data is noisy or contains periods of downtime. So the data needs to be cleansed in some way before you can even start doing your analysis. Another reason is that contextualizing the data or identifying time periods of interest is very difficult in Excel. Engineers end up spending much of their time data wrangling instead of performing actual analysis or identifying inefficiencies. This results in organizations being very data rich, meaning they have lots of data available, but information poor, and that they don't have the right tools to effectively leverage the data and get anything meaningful out of it. And finally, once we've built an algorithm for sorting and slicing and analyzing our data, we are probably going to need to do it again in the future with our spreadsheet on a whole new set of completely duplicated and stale data. Finally, once we've done these analyses and perhaps the subject matter expert has identified some valuable insights, a process for sharing that information within the broader organization for actions and decisions is not streamlined. Generally, organizations don't have a handle on all of the spreadsheets that might exist, which results in duplication of work, loss of knowledge, and ultimately decreased productivity. So all of these issues add up and result in valuable engineering resources and subject matter experts investing time and effort into data management tasks instead of actually solving problems. Workbench is Seeq's application for engineers engaged in diagnostic, descriptive, and predictive analytics with time series data. It includes features to expedite the full arc of the analytics process, from connecting to historians to data cleansing, visualization, modeling, and calculations. Key capabilities include a Google-like search on tag names and support for asset tree hierarchies to quickly find and define data for analysis, knowledge capture and real-time collaboration to create, share, and reuse work with colleagues and teams, extensive visualization tools for advanced trending, scatter plots, histograms, tree maps, and boundary management, business intelligent BI application integration to work with the tools you already use like Excel, Tableau, Spotfire, easy to use tools for many common data tasks such as searching within patterns, linear regression, and scatterplot visualizations, a rich scripting environment for ad hoc calculations, creating soft sensors from signal data and access to SQL data, and finally, integration with monitoring features so that insights found in analysis may be tracked against incoming data from the historian. Organizer is Seeq's application for engineers and managers to assemble and distribute insights as reports, dashboards, and web pages. These organizer topics may include text, images, scorecard items, and visualizations generated in Seeq Workbench, for example, charts, scatter plots, tree maps, and other content. Key capabilities include employees across the organization can leverage the insights created in Seeq with a read-only view of the information. Organizer is easy to use with a full, rich text editor to create compelling, informative documents for distribution. Distribution capability either as a URL or a PDF and including links back to the underlying data. Topics time ranges may be based on time, for example, every day or every shift, or on a Seeq capsule, for example, a batch or the state of an asset. And these time ranges may update in near real time. Updating a topic is as simple as auto recalculation based on the time range defined when they were created. And finally, if topics are created as a web page or URL, viewers may still leave contents for others while in a read-only mode. And these organizer topics are viewable in any modern HTML browser or on mobile devices as web pages or as PDFs. Data Lab is Seeq's application for data scientists and process engineers to access Python libraries to expand their analytics. Using Seeq Data Lab, process engineers can expand their Seeq analytics efforts to the rich ecosystem of Python libraries, and data scientists can participate directly in industrial analytics by leveraging Seeq for data access, cleansing, modeling, and other features. Seeq Data Lab is built on Jupyter notebooks and a Seeq Python library called SPY to access Seeq functionality and managed by the same administrative features as other Seeq applications. Seeq is a self-service analytics solution designated specifically for time series data analytics. Starting with the end user, the local research demand is very low. Seeq can be accessed from anywhere. A user can fire up their favorite modern browser, something like Chrome or Firefox, and get started. Within Seeq, there are hundreds of tools and capabilities available to the user, from flexible trending, data cleansing methods, math functions to perform basic calculus, like taking the derivative or integral of a signal, to more advanced functionality related to machine learning and pattern recognition. The hub between the user and the data is the Seeq server. The Seeq server is installed somewhere where it can access and connect to all the time series data sources. Whether this server is on-premise or in the cloud, the Seeq server provides all application features in a manner that is not only reliable, but also scalable. So whatever the size of the team, Seeq can be appropriately scaled to meet your needs. Seeq connects to all major data historians, SQL databases, or whatever time series database you might be using. Data can also be imported from standalone CSV files as well. All of this is to say that wherever you're storing your data, or if you're using multiple data storage locations, Seeq can index all of it and have it accessible from one location. In addition, Seeq is highly extensible with data export options that include exporting to Excel, PowerPoint, and any OData client such as Spotfire, Tableau, and Power BI. You can also create custom applications and templates with the Seeq REST API, and as well as SDKs for programming in Python, C#, MATLAB, and Java. Seeq requires minimal IT effort and is often set up in less than an hour, but this, of course, all depends on your tag count and the number of data sources that you want to connect to. Seeq can do many, many things, but we've broken it down into 4 main categories. The first is data alignment. You may have run into this when you're analyzing data in spreadsheets, that most likely data coming in from multiple data sources doesn't have identical timestamps, making any kind of quantification between the sources, or even different tags on the same source, extremely difficult. With Seeq, you don't have to worry about any of this. Seeq does all of the data alignment automatically and in the background. One of the main features of Seeq are the number of built-in user-friendly analytical tools that address topics such as data cleansing, quantifying KPI metrics, and monitoring a signal against boundaries, to name just a few. All of these tools are built on Seeq's advanced calculation engine. For more complex calculations, Seeq Formula can be used. Seeq also helps you visualize your data. Perhaps one of the most immediately apparent things upon opening Seeq is the ability to look at data in a number of different ways. The most obvious view is this flexible trending across time. We also have a number of other options, including scatterplot, histograms, scorecards, and tree maps. The last piece of the puzzle that I want to talk about here, and possibly one of the most important in terms of really transforming your processes, is the concept of knowledge capture. An engineer or subject matter expert can find $1 million process change or inefficiency, but if they can't communicate that finding easily and effectively, is it really worth anything? Seeq's organizer topic helps the user pull together their analysis into cohesive and auto-updating reports or dashboards that can easily be shared across the organization. With that, we'll get into some Seeq use cases. In this first use case, the customer produces an additive, and we'd like to quantify the amount of additive that was actually delivered to the customer. To determine how much actual product was delivered, we'll use the storage tank level of the additive to determine when deliveries occurred, then quantify some delivery metrics for each month throughout the year, as well as monitor the current month's metrics. These results will later be communicated in an automatically updating organizer topic. So we'll start by diving into Seeq's Workbench analysis. Workbench is where you, as the engineer, analyst, or subject matter expert, would bring in all the data and use the tools provided by Seeq to slice and dice the data, create models, identify boundaries, use pattern searching to identify similar performance, and keep track of all of this through Journal. So this is Seeq Workbench. The first thing that we want to do is search for the data we need for this analysis. In this case, we are looking for the tank level. So we'll do a search in the Data tab and select the tank level signal to bring it to our Details pane. Now I'll switch over to the Journal tab. The journal allows users not only to document their analysis, but they also can insert Seeq links to a specific view in this analysis. And since I've already developed this analysis, I'll be clicking through these links as I show you the use case. Once we've found the signal we are going to use, the first step is to identify each of the delivery events. Looking at my tank level signal, I can see that each event occurs when we have a level drop in the tank, which indicates that raw material is being removed for delivery. I need a way to capture or identify these level drops. One way to do that would be to take the derivative of my level signal. When I have the derivative, when the derivative is decreasing or below zero, the tank is draining. So we'll first start by taking a look at the derivative of this signal. In step 2, you can see that I'm taking the derivative of my level signal. And it's now present in lane 2 on my display pane. If I click Edit to show you the function that was used to take the derivative, you can see that I used the formula tool in Seeq to smooth the signal using our Agile filter function, and then apply the simple derivative function. As we expected, we can see that the derivative goes below zero when the tank level drops. To identify these periods of interest, we'll use a value search on the derivative signal. You can see that this value search identifies the level drop events as capsules. The capsules are shown as green bars at the top of the screen, and they make up a deliveries condition. I'll click Edit on the deliveries condition to show you the value search. You can see that I've just done a simple value search and identified when the derivative was less than zero to indicate a drop in tank level. Now that I have my deliveries identified, the next thing I want to do is just count the number of deliveries per month. Before I can count the capsules per month or aggregate my condition over a month, I need to create a monthly condition using the periodic condition tool. If I open up the periodic condition I just created, you can see that it's just a simple periodic condition that expands over each month of the year. It may look like one big capsule at the top, but if I click, you'll see that I can select individual capsules, each highlighting 1 month. So now that I have my monthly condition, I can count the number of deliveries that occurred each month. To do this, we'll use the Signal from Condition tool. Opening up this item, you can see that I use my deliveries as the input item, and I've selected to count the number of events bounded by my monthly periodic condition. Looking at this trend, I have a line indicating the number of deliveries each month. In addition, we would like to know the actual tonnage of material delivered. Therefore, we need to convert our tank level signal into an actual tonnage signal. We'll put this conversion on the display pane and see how it was accomplished. If I click Edit on that new signal, you can see that we use the Seeq formula tool to define the storage tank diameter and the density of the material, which are known in this case to be 12 feet and 1.02 grams per centimeter cubed, respectively. And then we can conduct some simple math to convert the tank level into actual tonnage. From there, we can again use the signal from condition to calculate the total tonnage per delivery. If we edit this calculation, we can see that we use the ton of additive delivered as the input, use the summary statistic of range, which is the max value minus the minimum value, and bound it by the delivery condition. This results in a new signal we see that indicates the total tonnage per level drop. Now we'll clean up our display to eliminate any signals and conditions that we are not interested in viewing in the final report. In our final report, we would also like to quantify some monthly summary statistics for KPIs over the entire year. We can use Scorecard View to display the results in a tabular form and define metrics using the Scorecard Metric tool. Here we are displaying the average, maximum, and total tonnage delivered each month, along with a number of deliveries. For example, if we edit our total tonnage, we see that we are using the Scorecard Metric tool. We're using the Scorecard Metric tool and measuring our tonnage delivered per haul, and then selecting to take the sum of all the deliveries over the course of each month. In a similar fashion, we are able to create a scorecard that measures the current month's metrics. For this example, we are monitoring the current number of deliveries and the last delivery amount, along with the average and max tonnage delivered just thus far. So in this example, we have demonstrated how Seeq can be used to search for data, quantify KPIs based on conditions, and monitor the results using scorecard metrics. At this point, I'm going to pause before going into organizer topic and take some questions.
Thanks, Nick. We only have one question right now, and that is if Seeq offers any training classes.
Yep, that is a good question. We do offer training as part of the initial deployment of Seeq by engineers like myself or analytics engineers at Swan-Black. And typically, by the end of training, we see that users are building out use cases for their organization and providing actionable insight. So we normally offer live training, but as people are often working from home nowadays, we have since deployed virtual training for learning Seeq with our customers, and we found that this virtual training has been equally as effective in getting your users to learn Seeq and apply it to use cases that are valuable in their organizations.
Excellent. Thanks, Nick.
Okay, so I'm going to move on. So going back to one of the previous slides, we've touched on 3 of the 4 important features of Seeq. So data alignment, analytics tools, and visualizations. Next, I'm going to talk about Seeq's knowledge capture capabilities. This is where we're going to document the results and create reports using Seeq Organizer Topic. In Seeq Organizer Topic, we will embed content from the Workbench analyses we created, set custom date ranges, and set the report to auto-update so that it is always presenting the reports based on the latest data. So organizer topic looks like any sort of word processing application you may be familiar with. I can add any text and formatting. You can see that in this report, I've used tables to give it some structure. I've also added an image of a Seeq logo. We can also include static hyperlinks or anything you may be familiar with adding to your reports. What's really useful about these organizer topics, however, is the ability to add Seeq content. As you can see, I've already added some charts and scorecard metrics from my previous exercise. I've made a note to myself to add the scorecard metric that quantifies our monthly totals over a year. So let's go ahead and do just this. I'm going to use the Seeq link button at the top to insert this content. I'll then select to add content from a worksheet, and then I can navigate to the tank level demo and select the quantify tank level metrics worksheet that we built. By default, the embedded content inherits the date range from the worksheet, but we can actually adjust that within the organizer topic. To do this, we add a date range from the Properties tab. I've already created a current month and last month date range, but since we would like this year's metrics, we'll create a date range for this year. To do this, we'll click the little plus symbol within the date ranges panel. I'll name this custom date range this year. One way I could accomplish this is by manually setting the start to January 1st and then setting the duration to 1 year. But instead, I'm going to set the date range by choosing a capsule within a yearly periodic condition and limit to the last capsule of the year. I'll choose to create a periodic condition and set the duration to yearly. I can select the capsule that I'd like, but for this example, I want to use the very last capsule closest to the end of the time window. So I'll keep this as it is. I want the scorecard to update daily, so here I'm going to select to auto update the display range. This makes the document live in that I can dictate how often I want the content in the dashboard to automatically update. For this example, I want the metrics to update every day, so I will set a rate of 1 day, and then I'll click Save. To apply this new time range to the scorecard metric, I'll click on it and click the blue Seeq link to update the Seeq content. I can now go down to the date range and select the this year date range we just created and click Insert. We see that the content in our organizer has inherited this new date range without having to go back and change the underlying analysis. Now that I've created my report, it's time to share this with my colleagues. There are several ways to do that. First, I can create a PDF, download it, save it, print it, email it, and do whatever I'm interested in doing using the download PDF button at the top of the screen. Or what we see our customers doing most frequently is using the Get Link button at the top and using the presentation view. The presentation view of this topic is a web page URL that contains an HTML version of the organizer topic. So what you're viewing right now is the URL that's hosting this topic. Anyone that navigates to this URL will be able to view the report and dashboard. Not only can they view the dashboard, but they can also click on the Seeq content to navigate to a view-only version of the analysis that was used to create it. It is view-only, so they won't be able to make any changes, but they can still read the journal, click through the analysis, adjust the date ranges, and get some more information about the steps that were used to create it. So you can see that these organizer topics are a great way to summarize results and share them with a wider audience. There's a lot of capability here that you can do for these organizer topics as far as knowledge capture and creating reports, documenting results, and then using the final product as a dashboard. So that concludes the organizer topic portion. With that, are there any more questions?
We do have a couple more questions at this point. The first question is, how long do I have to wait until my newest data is in Seeq?
That's a very good question. So when Seeq is initially installed and connected to the historians, Seeq will index all your signals and tags so it knows where to look when it's asked to retrieve data, but Seeq actually doesn't store any of your data. So because of this, Seeq can access your most recent data almost as soon as it's available in your historian or database.
Great. And the next question, can I limit who is able to view the report?
Yes, you can delegate who is able to view the report, and you can also give colleagues the ability to access and collaborate on the report as well. This isn't only limited to reports, but we can also do the same for workbenches as well.
That is all the questions we have right now.
Okay, so we're going to present one additional use case for this webinar. This one is slightly more advanced. In this use case, one of our customers had an induced draft fan, and this is a critical part of the cement manufacturing process. These fans are used to create a vacuum within the kiln to accelerate the drying process of the clinker. Any unplanned downtime of these fans are due to maintenance are extremely costly and cut into profits. So just like ceiling fans, these fans build up scales of dust on the blades over time, causing high vibration levels that can lead to the fans breaking down. Our solution is to use this vibration sensor to predict when the maintenance will be needed so that the fan can be taken down for cleaning. The result will be a predicted time in the future when the vibration limit will be reached, and therefore you can plan a less costly predicted downtime. So in the same way we started the truck delivery analysis, we'll begin by searching for our signals of interest. In this case, the engineer identified that the vibration is a good indicator to determine when maintenance or cleaning is required on these fan blades. And we'll start by bringing in this vibration signal, as well as a signal that indicates when the fan is on or off. Since sediment only builds up when the fan is running, we will use this tag to identify periods of time when the fan is off to eliminate them from the analysis. Here you can see that we will use value search to identify when the fan is off. Opening up the value search and shows that we will use the input signal ID fan motor state temp and search for when the signal matches the state off. So as you can see, value search can be performed on string signals as well as on numeric signals like we did in the truck haul use case. Our next step is to cleanse the signal by removing the periods of time when the fan is not running. For this, we'll use the formula tool. We can see that where you removed the motor off condition from the vibration signal with the remove function. Our subject matter expert suggests that maintenance or cleaning should occur when the magnitude of vibration reaches 0.4 inches per second in order to prevent the costly downtimes or repairs. This trip limit is shown as a scalar. Scalars in Seeq can be defined using the formula tool. For this, the formula is simply the value with the units following it. Here it is 0.4 followed by inches per second. In order to make a prediction, we first need to define the period of time when the data occurs, as well as some time into the future. This can be accomplished in several different ways in Seeq, but we have chosen a slightly more advanced way using formula. So we've defined a foreseeable run with a capsule that starts on September 2nd, 2015, and has a duration of 40 months, so just over 3 years. In the most simple of cases, we know that the vibration increases over time, but only while the fan is running. To predict this increase over time, we need to know how long the fan has been operating. Again, we can accomplish this using Seeq formula and the time since function. This function counts the number of days from the beginning to the end of the foreseeable run, but doesn't count when the motor is off. This results in a line that increases over time, but flattens when it reaches a downtime period. This flattening is more apparent when we zoom in a little bit on the display pane. Now that we have all the cleansed and generated signals required for the prediction, we can use the prediction tool to fit the data and forecast the results into the future. Looking at the prediction tool, you can see that we are trying to predict the clean vibration signal. Remember, this is the vibration data with the downtimes removed. And we're going to predict this using the time counter we created. We know that the buildup is linear over time. So for this example, we choose to use the linear model. Under the advanced options, we've decided to limit this prediction to only data in the foreseeable run. If we scroll down a little bit further, we can see some statistics about our fit, such as the coefficients to the model, the p-values, and the r-squared value. So an r-squared of 0.83 indicates that this time counter is a pretty good predictor of the vibration signal. We can now determine the end of run by taking the difference between the forecasted vibration and the trip limit. The crossing point is when this value reaches 0. So we've created a new signal that's the trip limit minus the forecasted vibration. And we can use value search to identify when that signal equals 0. So this use case was built on static data from 2015, but we can see that a predicted maintenance should have been scheduled for sometime around May 28th, 2018. So this was an example of how you can use Seeq to quickly and easily develop a predictive maintenance schedule to avoid downtimes and increase profit margins. So with that, do we have any last questions?
We do. The first question, I have all my calculations done in Excel already. Seeq looks cool, but why would I transfer all of my calculations from Excel to Seeq?
Thanks for that question. So there's a lot of advantages to putting it in Seeq and over using those calculations already defined in Excel. So there's a lot of functionality that we haven't discussed, such as the ability to scale your analysis to other assets by using the built-in asset swap functionality or to visually compare the performance of multiple assets as once using our tree map view. But I think that the most convincing reason is not having to duplicate your data or duplicate your spreadsheets with stale data. With Seeq, you can just adjust and iterate your workflow really easily, which gets you to your solution a lot quicker. So, and Seeq, once you've honed in your analysis on a narrow span of time, Seeq allows you to easily expand that. For example, in that first use case, we initially did it on just a month of data, but we can quickly expand it to the entire year.
Great. The next question, how often is the software updated?
So our developers are constantly improving our software. We release updates and what we call release trains, excuse me. And essentially what that means is that we have a major release about every quarter, with new features being added about every 6 weeks and bug fix releases about every 2 weeks.
Wonderful. Well, that's all the questions that we had right now, but if you have any additional questions, you can reach out to Joseph Gardner at swanblack.com. And Joe, do you have anything you'd like to mention?
I think that's it for me. Like I said at the onset, and like Elise said, if anybody has any questions, feel free to reach out to me. You have my contact information here. I would also encourage everyone, if you feel so inclined, to follow us on LinkedIn, and we also have a YouTube channel that you can follow with some more advanced use cases that we walk through. So please don't hesitate to reach out. And thank you again, everybody, for joining. Really appreciate your time.